Good evening, everyone. I am Sibi Sarida from Grade 10 St. Nicholas, and tonight I'll be discussing permutations and combinations. What is permutation and combination? In mathematics, permutation is the act of arranging the members of a set into a sequence or order, while combinations are a way to calculate the total outcomes of an event where order of the outcomes does not matter. Please remember that the exclamation point can be signified as a factorial function, which means to multiply a series of descending natural numbers. Here are some examples. 4 is equal to 4 times 3 times 2 times 1, 24. And 7 is 7 times 6 times 5 times 4 times 3 times 2 times 3 times 1, 5040. And 1 is just 1. Also, it is generally agreed that 0 is just equal to 1. It may seem funny that multiplying no numbers together gets us 1, but it helps simplify a lot of equations. These are two types of permutation. One is permutation without repetition, wherein you can reuse the same element within the order. And 2, permutation without repetition, wherein each element can only appear once in the order. Here is the example of permutation with repetition, shown here. How many 3-digit numbers can be formed with the digits 1, 2, 3, 4, 5, wherein n is equal to 5 and k equals 3? The order of the elements does matter, and the elements are repeated. Permutation with repetition, 5 and 3 equals 5 to the power of 3 is equal to 125. So the formula is simply n to the power of repetition, where n is the number of things to choose from, and we choose r of them. Repetition is allowed, and order matters. Here is another example. How many 9-digit numbers can be formed with the numbers 2, 2, 2, 3, 3, 3, and 4, 4? Wherein n is equal to 9. And a is equal to 3 because there are 3 2's. And b is equal to 4 because there are 4 3's. And c is equal to 2 because there are 2 4's. So it is a plus b plus c equals 9. The order of the elements does matter, and the elements are repeated. To solve for it, 9 with factorial function over 3 times 4 times 2 with factorial functions respectively is equal to 1260. Our next example is permutation without repetition. A license plate begins with 3 letters. If the possible letters are A, B, C, D, and E, how many different permutations of these letters can be made if no letter is used more than once? The formula for permutation is P open parenthesis N and R close parenthesis equals to the power of N P and sub R equals sub N P sub R equals n factorial function over n minus r with factorial functions respectively. To solve for it, sub 5 p sub 3 equals 5 with factorial function 5 minus 3 with factorial function equals 5 with factorial function over 2 with factorial function is equal to 5 times 4 times 3 times 2 with factorial function over 2 with factorial function is equal to 60. Therefore, there are 60 different permutations for the license plate. Now let's talk about combinations. There are also two types of combinations. Repetition is allowed, such as coins in your pocket, 5, 5, 5, 10, 10. But no repetition, such as lottery numbers, 2, 14, 15, 27, 30, 30. Here's the example of combination with repetition. There are 5 different types of bottles in a wine cellar. How many ways can 4 bottles be chosen from the cellar? The order of the elements does not matter, but the elements are repeated. The formula for a combination with repetition is combination with repetition n and k equals n plus k minus 1 over k is equal to n plus k minus 1 with factorial function over k with factorial function n minus 1 with factorial function. To solve, C 5 and 4 equals 5 plus 4 minus 1 with factorial function over 4 with factorial function 5 minus 1 with factorial function equals 8 with factorial function over 4 times 4 with factorial functions respectively is equal to 70. Another example is this. There are 3 flavors of ice cream: chocolate, lemon, and vanilla. You can have 3 scoops. How many variations will there be? Let's use the letters for the flavors C, L, V. And these are the possible selections. So using the formula, C with repetition N and M equals N plus M minus 1 over M equals N plus M minus 1 with factorial function and with factorial function N minus 1 with factorial function. CR sub 3 and 3 equals 3 plus 3 minus 1 over 3 equals 5 over 3 and equals 5 with factorial function over 3 times 2 with factorial functions respectively is equal to 10. Here we have the last example. Combination without repetition. This is very interesting because it's about lottery. The National Lottery is a lottery game in which you have to deal with 6 whole numbers between 1 and 49. How many possible combinations of 6 numbers are there? If a combination of 6 numbers costs 1 pesos, how much would you have to pay in order to ensure that you have chosen the winning combination of numbers? The formula for a combination without repetition is C open parenthesis N and K close parenthesis equals N with factorial function K with factorial function N minus K with factorial function. To solve, C sub 49 and 6 over 49 over 6 equals 49 with factorial function over 6 43 with factorial functions respectively is equal to 13,983,816. So you have to waste 13,983,816 pesos to be sure you have chosen the winning combination of numbers. Here is my comparison chart. Shown here, the meaning of permutation is a reference to the different ways of arranging a set of objects in sequential order, while the meaning of combination is a reference to several ways of choosing items from a large set of objects, such that their order does not matter. The order of permutation is relevant, while the order of a combination is irrelevant. It denotes arrangement by the permutation, while the combination denotes selection. So what is it, by the way? Permutation has ordered elements, while the combination has unordered sets. Permutation answers the questions: how many different arrangements can be created from a given set of objects, while the combination answers the question: how many different groups can be chosen from a larger group of objects. And lastly, the derivation. The permutation derives multiple permutation from a single combination, while the combination derives single combination from a single permutation. With the above discussion, it is clear that permutation and combination are different terms, which are used in mathematics, statistics, even research, and our day-to-day life. A point to remember regarding these two concepts is that for a given set of objects, permutation will always be higher than its combination. I hope you learned something. This has been CV Sarida. Thank you for watching, and stay safe. Adelante!